This video is a continuation of last night's lesson where we have to be able to solve multi-step word problems with numbers in any form. And tonight we're going to focus more on fractions. Last night's focus was really on decimals. But it says I can apply properties of operations to calculate multi-step problems with numbers in any form. And tonight again we're going to focus mostly on numbers in fraction form. So let's take a look at this first one. Part of this standard, we have to discuss estimation. So in last night's video, I didn't explicitly say it was part of the standard, but you saw me estimating how I knew 18.80 times 40 was approximately, things like that. Tonight, the question is going to specifically ask you to estimate, and that's another way the state could ask it. It says Trent is fishing from a pier. The tip of the fishing rod is 53 3/4 feet above the surface of the water. The hook on the end of the fishing line is directly below the tip of the fishing rod, but it's 12 2/3 feet below the surface of the water. Trent estimates the distance between the tip of his fishing rod and the hook is less than 65 feet. Is Trent's estimation reasonable? Explain your answer. Okay, as I look at this problem, probably the first thing I would choose to do is get a little picture going. So he's got this fishing rod, pretend it was going straight across. And from that fishing rod, he drops a line down. And 53 3/4 feet down, you have the surface of the water. So he's saying if you go a straight line distance down, if you go down 53 3/4 feet, you'll hit the surface of the water. And then that fishing line continues underneath the water. And then at the bottom, there's this little hook. And he says, okay, but below the surface of the water, the fishing hook is going down an additional 12 2/3 feet. And so we know the 53 3/4 was above the surface of the water. We know the 12 2/3 feet was below the surface of the water. He estimates the distance from the tip of the fishing rod and the hook, so if he goes all the way down here to the hook, he estimates that distance is less than 65 feet. Is his estimate reasonable? Explain your answer. Okay, so if you have 53 and some feet above the water, 12 and some feet below the water, the question is there a way for that total distance to be less than 65 feet? Well, here's one thing that you could do to figure out the estimate. You could just ignore the fraction part. And you could say, okay, if I need my total and I just pretended it was just 53 feet, even if we didn't care about that extra 3/4 above the water, 12 feet, even if I didn't care about that extra 2/3 below the water, what would the total be? And would that be less than or more than 65? 3 plus 2 is 5. 5 plus 1 is 6. Gosh, not even caring about the extra fractional part, if we just add those whole numbers together, we're already up to 65. And since our actual numbers, the first number was more than 53, the next number was more than 12, 65, that estimate is a little bit too low. So to be less than 65, no way. His estimation is not reasonable. So I'm going to start my discussion with that, and then I'll show you a second way you could have chosen to estimate. So he says that the total distance is less than 65. Is Trent's estimate reasonable? No. Trent's estimate is not reasonable because if we just add the whole number parts, 53 feet above the water and 12 feet below the water, we arrive at a total of 65 feet. So there's no way it's less than 65 feet. The actual numbers were more than 53. It was 53 3/4. Oops. And more than 12. The actual number was 12 2/3. So there's no way the lowest possible estimate we could come up with would be 65 feet. Another way you could have looked at this is you could have taken the 53 3/4 and said, is that closer to 53 or closer to 54? Well, if you just think about 3/4, 3/4 is almost getting to another whole circle. So really, if we were going to round this number to the nearest whole number, we'd actually round it up to 54. If I took this 12 2/3, well, if I look at 2/3 of a circle, is that more than half of the circle? Yeah, it sure is. So if I was going to round this one to the nearest whole number, I'd round that 12 2/3 up to 13. If I then added 54 and 13, the upper estimate for this problem would probably be 67. So my guess is that this fishing rod, the total length from the top down to the hook of that line that's been dropped is between 65 feet and 67 feet. But less than 65 doesn't have a shot. Okay, so that's just one part of what the state might ask you. They might ask you for reasonable estimates and why certain estimates are reasonable. Now they're going to ask you to take this information and do some more with it. Now, same situation. So we still have our fishing rod. The top of the line is still 53 3/4 feet above the water. The hook, right now, it was 12 2/3 feet below. So we still have that initial situation. But then it says Trent lets his hook drop another 10 inches. Oh, so he's going to drop the line even a little bit further, just a little bit further, another 10 inches he's going to drop that line. What is the distance in feet between the tip of the fishing rod and the hook? Do not round your answer. As soon as it says do not round your answer, I know they want this answer in fraction form. You could switch it to decimals, but then you'd have a repeating decimal. It would just be a lot to handle. All right, the other piece to this problem is they're giving us 10 inches, but they want our answer in feet. So we have to think about 10 inches is how much of a foot? Well, 12 inches is 1 foot. We only have 10 inches. We only have 10 inches. So this is less than 1 foot. So 10 inches is less than 1 foot. So if I look here and I broke this into 1, 2, 3, 4, 5, 6, this is ugly, 7, 8, 9, ooh, ugly, 10, 11, 12. If I know I have 10 inches out of 12 inches, what would that be as a fraction? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 10 out of how many? 10 out of 12. So 10 inches is actually 10/12 of a foot because there's 12 inches in 1 foot. So it's almost a whole foot, but not quite. And I could simplify 10/12. So hopefully you see that. 10 inches is 10/12 of 1 foot because there's 12 inches in a foot. I could simplify this. I'm just going to divide top and bottom by 6 just to write my answer in simplest form. 10 divided by 6 is, I'm not dividing by 6, I'm dividing by 2. Oh gosh. 10 divided by 2 is 5. 12 divided by 2 is 6. So 10 inches equals 5/6 of a foot. Okay. So now we know we have 5/6 extra of a foot. And they want to know what's the total distance between the top all the way to the bottom. So the big question is, what am I going to do with my 53 and 3/4, my 12 and 2/3, and my 5/6? Hopefully, you see, we're just going to add them up. 53 and 3/4, 12 and 2/3, and then we have to add on this 5/6. Now this is a throwback to our signed numbers unit where we had to be able to add and subtract signed fractions. Thankfully, these are all positives. But we know when we want to add fractions, we have to find a common denominator. Oh, look, I'm going to put this back to 12. Oh, well. So this is 53. Between 4, 3, and 6, the smallest number they all divide evenly into is 12. So I'm going to rewrite them each as 12ths. So this is going to be 12 and some number of 12ths. And then this, there's no whole number in front, so I'm just going to convert that to 12ths. 3/4 is how many 12ths? 3/4 is the same as 9/12. 2/3 is how many 12ths? 2/3 is the same as 8/12. And 5/6 is how many 12ths? 5/6 is the same as 10/12. Now we're just going to go ahead and add those up. 9 and 8 is 17, and 10 more is 27. Is that 27/12? I hope. And then 53 plus 12, 3 and 2 is 5. 5 and 1 is 65. So 65 and 27/12. First of all, I say, is this reasonable? This sure is reasonable. I knew my answer would be somewhere between 65 and 67. But I'm not leaving this as 27/12. Oh, and we had this extra little 5/6 that might now be more than 67. But I can't leave this as an improper. So what I really have to do is 65 plus 27/12. 27/12. If I convert this back to a mixed number, how many times does 12 go into 27? 12 goes into 27 2 whole times. 2 whole times with the remainder of 3. So with 3/12 left over. So it goes in 2 whole times with an extra 3/12. And then I could simplify that. I could simplify that if I divided numerator and denominator of that by 3. That's actually 2 and 1/4 would be in simplest form. So then I'd have 65 plus 2 and 1/4. 65 and 2 is 67 and 1/4. Okay. And it makes sense because our original estimate between these two numbers was between 65 and 67. I tack on a little bit more. It makes sense that my final answer is a little bit over 67. So there you go. That's another lesson on being able to solve multi-step problems with numbers in any form. And New York State is no joke. When they say multi-step problems, they mean these problems take a lot of time, a lot of effort, a lot of energy. I hope that helped. Try to have a good night.